All right, so a common motif in proteins is this disulfide bridge. So we already learned about this a little bit. Anytime you have thiols, you can react them to form a disulfide. So a sulfur-sulfur bond. And we have these present in amino acids. The amino acid that we're interested in here is cysteine because it has that thiol group, which can form the disulfide bonds. Overall, this concept is very important in protein folding / structure, which then in turn makes it important for the function of the protein. So let's just take a look at a couple examples of that. So in this case, in this depiction, right, we've got our N terminus over here, our C terminus over here, and then each one of these little circles represents a separate amino acid. And you can see how there's disulfide bridges in between them. And so obviously the location of them would then determine the structure and the function of the compound. Same thing with this picture right here, right? You can see a protein just drawn a different way, right? All of these kind of like loops and folds, they just represent chains of amino acids structured in different ways. And then you can see, right, there's disulfide bonds. In this case, this is a paper about some artificial disulfide bonds. But the important part to note here is that just these disulfide bonds play an important role in the structure of the compounds. And then, of course, a popular example used is hair perm. So if you don't know what that is, it's when you go get your hair permed, you go from basically kind of straight hair to curly hair. And the way that you do that is through breaking and forming these disulfide bonds. So for example, you start off with in your hair, there's a lot of these disulfide bonds. So you can see they're bonded. We add some kind of reducing agent to break this disulfide bond. Then you put them in a curl or whichever way you want to organize your hair. And then you reform the disulfide bonds, and then your hair is then stuck in that structure.